Assalamu alaikum warahmatullahi wabarakatuh. In this video, we are going to talk about solving equation system using matrix inverse. First of all, we will have equation system like two equations in two unknowns or three equation with three unknowns. As we are saying now, number of unknowns should equal to the number of equations because we are going to make a matrix, square matrix, so it should be 2 by 2, two unknowns, two equations, or 3 by 3, three unknowns and three equations, and so on. Of course, as we mentioned in determinant, we have three cases: unique solution and no solution and infinite number of solution. If they are collinear or at the same line, we will have an infinite number of solutions. If they are parallel, we have no solutions. If they are intersect in one point, so we have a unique solution. Okay, first of all, we have to rearrange the equation. Here we have x plus y plus 2z equal 1. So if I started with x, all equations have to start with x. So here to x and x, okay, plus y. Then the next unknown is y. If the unknown is not exist in any of those equations, like here there is no z, we will assume that it's plus 0 z. So the coefficient of the z here is 0, and 0 times z equals 0, and it wasn't written here. So we have three equations: x plus y plus 2z equal 1, 2x plus y plus 0z equal 2, x plus y plus 2z equal 3. Now we are going to make or create three matrices. The first matrix is the coefficient matrix, or matrix of coefficient, the coefficient of x and y and z. So the coefficient of x here 1, 1, 1, 2, 1. Coefficient of y 1, 1, 2. Coefficient of z 2, 0, 2. This is the first matrix called matrix of coefficient or coefficient matrix. The second matrix is, let's erase the second equation. The second matrix is the unknown matrix x, the unknown matrix x equal. In this matrix we put our unknowns. The first unknown is x, so the first element is x, y and z, variables or matrix of unknowns or unknowns matrix. The last matrix, which is R or B, some books denoted it by R or by B. The right hand side constants the right hand side constant. We have constants here in the right hand side, 1, 2, 3, 1, 2, 3. So we create those matrices. As we said, this is the first matrix, the coefficient or matrix of coefficient A, the matrix of containing the variables x, y, z, and the column matrix B containing the number of on the right hand side or on the equal sign, which is a constant matrix. So we have two column matrix, the unknown matrix and the constant matrix are column matrix, while the coefficient matrix or the matrix of coefficient is a square matrix. Then we have to apply in an equation. This equation is start from A time x equal B till it reach the final shape, which is A minus 1, which is the inverse, times B equal x. So we have the x matrix, we have B matrix, which this is B and this is x, but we don't have the inverse of A or A power negative 1. How to get the inverse from this original matrix? That's what we are going to do right now. The first step is making sure this is not a singular matrix, because if it's a singular matrix we can't have inverse for it, and so we don't have a unique solution, or we can't solve this equation system using matrix inverse. So the first step is evaluating the determinant of the square matrix or the coefficient matrix of coefficient. Okay, the first step, as we said, is calculating a matrix delta determinant A between vertical bars, as we said, or we can write det the determinant A is a determinant one, two, one, 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 two, two, 0, 2. Then we repeat the first two columns, which are 1 to 1 and 1, 1, 2. Then the going down diagonal 2 plus going down diagonal 0 plus going down diagonal 8. So the going down diagonals equal 10. The going up diagonal, which is 2, 0, and 4. So determinant A equal 10 minus 6, 2 plus 0 plus 4 equal, of course, 6. 10 going down diagonal minus going up diagonal will equal 4. So it's not the important thing, it's not equal 0. It's not a singular matrix, so we have a unique solution. Okay, how to get this unique solution? That was the first step, calculating the determinant. The second step is calculating the minors and cofactors, or the matrix of minors and matrix of cofactors. To create the minor, what is the minor? The minor is the minor of an element is the determinant remain after deleting the row and the column of this element. We have here 9 elements. If we call this A matrix, so we have A11, A12, and A13. Okay, the minor of an element, as we said, for example, the minor of the element A11. A11 in the first row and the first column. So we will remove or cancel out the first row and the first column. What left, which is 1, 0, 2, 2, this determinant, which is 1, 0, 2, 2, is called the minor of the element 1, 1 or M11, which equal the main diagonal 1 by 2, which is 2 minus 0, so M11 equal to. Okay, the minor of the element A12, which we'll call M12. The minor 1, 2 come from the element A12 after neglecting or cancelling out or exclude this element row and this element column. Element 1, 2, which is here, we cancel out its row and its column. So we get a determinant 2, 1, 0, 2, 2, 1, 0, 2, which equal 4. So minor 1, 2 equal 4. And so on. Minor 1, 3. Minor 1, 3 comes from removing or cancelling the first row and the third column. So we will remove the first row and third column. We get 2, 1, 1, 2, which will equal 4 minus 1, 4 minus 1, 4 the main diagonal, minus 1 the secondary diagonal, which is 3. Minor 2, 1 equal minor 2, 1 as its name, second row, first column. We will cancel out the second row and the first column. We will cancel the second row and the first column. So we get 1, 2, 2, 2. 1, 2, 2, 2, which will equal 2 minus 4 equal minus 2. And we will continue that till we get the whole matrix of minor. Matrix of minor will be 3 by 3 matrix, will called M, or denoted as M, or as A minor, M-I-N-O-R. A minor or M, we have, as we said, 9 elements, which is M11, M12, M13, M21, 22, 23, وهكذا. As we said, the first element was 2, then 4, 3, negative 2, and let's remove those to calculate the other minors. We need to calculate the minor M22. M22, we will remove or neglect the second row and second column. Second row, second column. So we get 2 minus 2 will equal 0. Then we want to calculate M23 by cancelling out the second row and the third column. So we have 1, 2, 1, 1. The main diagonal is 2 minus secondary diagonal is 1. So 2 minus 1 equal 1. The M31, something like that. M31, we will cancel out the third row and the first column. Third row, first column. So we get this determinant 1 by 0, the main diagonal minus secondary diagonal. 0 minus 2 equal negative 2. Negative 2. Minor M3, 2. We will cancel out the third row, second column. Second column. So we got 1, 2, 2, 0. 1, 2, 2, 0. 0 minus 4 equal negative 4. Negative 4. The last minor M33, of course it comes from cancelling out the third row and the third column. So 1, 1, 2, 1. The main diagonal is 1. minus secondary diagonal is 2, 1 minus 2 equal negative 1. So we have here matrix of minors, or as we said, it can be denoted as M or A minor. هذا النمر الوردي؟ هذا. After creating the matrix of minor, which is M or A minor, this matrix, we need to get another matrix, which is cofactor matrix, or the matrix of cofactor. How we calculate the cofactor? Using this equation, Cij, the cofactor for the element in the row of I and column of j, equal negative 1 power I plus j times m, which is the minor of ij. So the cofactor rely on the minor. The matter of fact, they both have the same absolute value, but they might have the same sign, positive or negative, or different signs, as we going to see right now. So, for example, if we want to calculate the first, we need to create a matrix of cofactor. Some call it C or A cofactor. We have 9 elements: C11, C12, C13, C21. So let's calculate C11. C11 equal, as the equation said, negative 1 power I plus j. I here equal 1 and j equal 1. As we said, the I is the number of row which the element is and he's in the it's in the first row, and j for the column. So ij equal 1 plus 1. So it's negative 1 power 2, which is equal positive 1, times m11. m11, which is here, this element is m11, which is equal to, so we have negative 1 power 2, which is equal positive 1, times 2 will equal 2. So here the cofactor equal to, it's the same value as the minor. Okay, let's calculate C12. C12, the same equation, negative 1 power I plus j. I here equal 1, number of row plus number of column, which is 2, 1 plus 2, times m12, which is 4. So here is 4. Negative 1 power 3 equal negative 1. Negative 1 times 4 equal negative 4. So the cofactor here will be negative 4. So it changed sign. Here the minor was 4, while the cofactor negative 4. They have both the same absolute value, but not the same value or not the same sign. C13, C13 will equal negative 1 power 1 plus 3, which is 4. So we have negative 1 power 4 equal positive 1. Positive 1 times m13, which is the 3 here, m13. So positive 1 times 3 equal 3. The same way, it's a line here, C2 1, C2 1 equal negative 1 power 2 plus 1 times m21, which is negative 2. This is time negative 2. We have here negative 1 power 3, which will equal negative 1 times or by negative 2, which is the m21. So negative 1 times negative 2 will equal positive 2. 0. We can use the same equation, or we know that 0 by any number will equal 0. Then the cofactor, of course, this 0 is C22, C22 equal 0, because as we said, it's m22 plus times negative 1, and 0 by anything equals 0, so it's 0. C2 3, 2 second row, 3 second third column equal negative 1, negative 1 by power 2 plus 3, negative 1 by power 5 equal negative 1, of course, times C m23 here equal 1, m23 equal 1. So negative 1 by 1 equal negative 1. With the same way, we can have C31 third row first column equal negative 1 power 4, 3 plus 1, which is 4, times m31, which is negative 2. So negative 1 power 4 equal positive 1. Positive 1 times the negative 2 will equal negative 2. We can erase this. C3 2 third row second column, negative 1 by power 3 plus 2 times m32, which is negative 4, negative 4. So we have negative 1 by 5, which is negative 1, negative 1 by negative 4 equal 4. So we have 4 here, and the last element in the cofactor matrix, which is C33 equal negative 1 power 3 plus 3 times m33, which is -1. So we have -1 by power 3 power 6 equal +1. +1 times -1 equal -1. And now we got the cofactor matrix or a cofactor. This matrix will called C or a cofactor. After calculating the cofactor, we need to get the last matrix, which is a adjoint edge or a adjoint equal the transpose of the a factor, transpose of a cofactor. We get the transpose as we said before by interchanging or by changing rows to columns or columns to row. So a edge will equal, we will change the first row to be the first column to -4 3. It's the second row to be the second column to 0 1. Third row to be the third column or changing columns to rows. So the first column will be the first row and the second column will be the second row, third column, third row. And this is called a adjoint or the adjoint. Let's write it in a better way. After we write down the adjoint, as we said, the adjoint is the transpose of the cofactor. The last step is calculating the inverse by the equation A bar -1, which is the inverse of matrix A, equal the adjoint A edge or adjoint over the determinant of A. So I need, which is equal, we calculated the determinant was 4, so I'll multiply 1 over 4 times this whole matrix, or divided 2 by 4, 2 by 4, -2 by 4, -4 by 4, and so on. So it will be like 2 over 4 equal half, 2 over 4 equal half, -2 over 4 equal negative half, -4 over 4 equal -1, 0 over anything equal 0, 4 equal 1, 3 over 4, 1 over 4, and negative 1 over 4. Now we got the inverse, and the last step, as we said at the start, by using the equation a negative 1 times the constant matrix, which is B, equal the unknown matrix, which is X. So in the next step, we will multiply this matrix, which is the inverse, times the matrix of constant, which were in the right hand side, and uh, equal this product, multiplication product with X or the unknown matrix. As we said, we have this equation X, the unknown, equal inverse of A times B. If the matrix, the inverse exists, as we said, exists uh, when and we know that the inverse exists when delta, when the matrix is unsingular, non-singular, um, when determinant of the matrix is not equal to 0. So by multiplying the inverse by the matrix B, which were the constant matrix, the A is 3 by 3 matrix, B is 3 by 1 matrix, so the inside dimensions are equals, so the multiplication can be done, and the result or the answer will be 3 by 1, which is 3 rows 1 column. So X equal the inverse times the constant. We will multiply it and see the result. When we multiply the inverse by the constant, so we have the unknown matrix, which is equal X equal the inverse times the constant. We will multiply the first row by first column to get this element, and x1 x21 from second row times first column, x31 from third row by first column, and this equal the matrix of unknown, which is x y 0. And as we know, when two matrices are equal, so each element is equal its corresponding element, so x will equal 0, y equal 2, and z equal negative half, and it can be written as an order of triple of numbers. The solution will be the coordinates of x 0, coordinates of y 2, the coordinates of z, which is negative half. So this is the intersect or the solution for this equation system. We can, if you calculate or training at home, you can use Excel to get the inverse and to get the multiplication, as we said. So in the next and the last section, we will try to get the inverse using Excel, and this multiplication using Excel. As we said, we are going to use Excel to help us solving this equation. So the first, we have the matrix of A, 1, 1, 2. We will write it down, 1, 1, 2. And the second row was 2, 1, 0, 2, 1, 0. The third row, 1, 2, 1, 1, 2, 1. As we said in the first, we want to calculate determinant of A to make sure it's not a singular matrix. We will use the order of the equation equal M for matrix, det term for determinant. So it will ask about the array or the matrix. We will select our matrix, then we will press enter. We have M determ. Let's make sure it's written in a good 1, 1, 2, 2, 1, 0, 1, 2, 1. Logo. So after we wrote down the matrix, we will calculate its determinant, as we said, that A, and here equal matrix determ return the matrix determinant of an array. So the array, select our matrix and control and enter, press enter. It will be 4. It's of course non-singular, so one solution. The next step, to calculate the inverse, A power -1 or inverse. Here we will write down equal M for matrix inverse INV, M inverse, return the inverse of matrix for the matrix stored in an array. Ask about the array. This is our array, and we will press enter. So we have our inverse. Then if we want to make the multiplication, we will write down here, let's make it a blue or something, the constant were 1, 2, 3. So here 1, 2, 3, and the multiplication, we want to calculate the x, y, z, which are the unknowns. So here we will write down equal M for matrix multiplication, which returns the matrix product of two arrays. Of course, here he wrote the dimension, the condition is wrote the same number of rows as array 1 and columns array 2. Okay, we will select the inverse, then comma, and array 2, the constants, and we will press enter. we have x and y and z. So we can use the Excel to calculate the determinant, to make sure that you calculate the determinant right, to calculate the inverse, to make sure that we calculate the inverse right, and to multiply the inverse time the constant. Okay, what if we have equation system like this one, and after creating the coefficient matrix we found it's singular, because as we see the first column is identical to the third column. So this, if we want to get the determinant will equal 0, because from the determinant properties, if two rows or two columns are identical, then the determinant equals 0. And this matrix determinant equals 0, so it's singular. So the inverse of this matrix doesn't exist. So we can't solve this equation system using the inverse, or using the matrix inverse. Cases when the matrix techniques don't work. We can't solve the equation system using matrix inverse in two cases. The first, if the coefficient of matrix is singular, as the previous example, and if the number of variables is not the same as the number of equations. As we said, the matrix A matrix should be square, so it should be 2 by 2 or 3 by 3, or of course 4 by 4, and so on. To be that, the unknowns, which is x, y, z, or a, b, c, or x1, x2, x3, whatever the letters, the unknowns should be equal to the equations. If they are not equal, so we can't use the matrix inverse to solve this equation system. And now we finished. I hope you understand what uh, we learned today. And Assalamu alaikum wa rahmatullahi wa barakatuh.